All right. All right, so let's do that. So let's subtract those two polynomials. So do you remember how this works? What do you do with a minus sign, specifically right here, this minus sign that's in front of those parentheses? What do we do with that minus sign? Do you remember?
Distribute.
Yeah, distributes. Anything in front of a parenthesis, a minus sign, a number, anything like that, needs to distribute. It needs to go to all three of those. It's going to hit the 8x squared, it's going to hit the minus 5x, and it's going to hit the plus 9. Remember that any sign in front of a number or letter, that's his sign. So what I mean is that negative is on the 5x. I know we think of it as kind of being between them, but really it belongs to the 5x. It's his baby. And this plus sign is on the 9. And there's no symbol in front of the 8x squared because the parentheses right there. But then this minus sign that's in front of the whole parenthesis will visit and hit all three of them, changing all three signs. So that'll become, here, these guys, I'm just going to recopy them, no change. They have no, notice they don't have a minus in front of them, do they? So their signs are not going to change. 5x cubed minus 9x squared plus 5x plus 5. So I just recopied those four, no changes at all. But then the other three, here we go. Minus is going to hit the 8x squared. The minus is going to hit the minus 5x to make it plus 5x, right? Did y'all see the two minuses hit there? Minus and a minus hit to make plus. And then the minus is going to hit the plus 9 to make minus 9. Remember that kind of stuff? So that minus sign in the front of that second parenthesis hit all three of those, changing all three signs. And now we just need to combine like terms. What are like terms? You remember that from algebra? Terms with the same power. So 5x cubed, is there any other x to the third power terms? Nope. So he's in a category by himself. He won't combine with anybody. Just bring him down. Next, minus 9x squared. Do we have any other x squared terms? Yeah, negative 8. So they'll combine together. The numbers in front combine. So we got a minus 9 of those x squared things and minus 8 of those x squared things. So if you lose, just negative is like losing money, right? If you lose $9 and you lose $8, how's your bank account affected? You lost 7. You just add them up, huh? 9 and 8 is 17. You can use calculators and homework and tests and everything. So minus 17x squared, just combined like terms there. And now 5x and plus 5x and plus 5x. Plus 10x. And finally, plus 5 and minus 9. If you gain $5 and lose 9, your bank account is down 4. And that's the answer. We're done with number 1. Is that good? Questions on that one? All right, let's try number 2. So number 2, we've got that 8 in the front there. So what does a number in front of parentheses always do? It multiplies, yeah. So take that 8 and go boom, boom, boom. And then the other one is a minus 8. Remember, that minus is on that second 8. And he also is going to go boom, boom. So let me let you try that. So the 8 distributes, and we get 32. It's multiplying, right? 8 times 4 is 32, y squared. 8 times minus 7, minus 56. Oh, not y squared, just regular y, huh? Feel free to use the calculator if you're rusty on some of these times tables. 8 times 3 is 24. It's positive because it's positive 8, positive 3. So those three are done. Now for the back three, now careful, it's going to be negative 8. Not just 8. That minus sign is his baby. Remember what I was saying? That any sign in front of somebody, that's their baby. It goes with them wherever they go, right? It's attached. So that negative 8 times 3, negative 24. And negative 8 times negative 4y squared, is plus 32y squared. Good so far? See the signs on that? Now let's combine like terms. Start with the highest power, 32y squared, and another 32y squared. 64y squared, right? They combine. You just add the numbers in front. You don't mess with the powers, huh? You don't make it y to the fourth. Why not? When do you do that? There is a time when you're multiplying them, which we'll do in a minute on number 3. But now we're just adding. Question?
We take them out of the parentheses?
Oh, yeah, good question. When do the parentheses drop? Whenever something from the outside of a parenthesis goes in, drop the parentheses. Yeah, good question. Thank you. Yeah, when that 8 went in, I dropped them, and when the other negative 8 went in, that's when you drop the parentheses. Yeah. And now we just keep combining things. Minus 56y. There's no other regular y terms. And then 24 minus 24 just cancels, huh? And so we're done. It's just 64y squared minus 56y. Let's try number 3. See what you remember about multiplying letters now. I'll give you a second. Okay, so x, the x is going to multiply in. Now, what happens when letters multiply each other? Yeah, the powers. That's right. Now, what power is on this x that's in the front? I don't see a power. It has an invisible 1, doesn't it? Do you remember that kind of thing? If there's no power showing, it means there's really an invisible 1 because there's only one x there, huh? So that x to the 1 multiplies x to the 4, and the powers add to be x to the 5 plus. So this x went there. Next, the x to the 1 hits the other x to the 1, and the invisible 1 powers add to be 2. And finally, the x to the 1 hits the minus 6 at the back, and that's minus 6x. And that one's just done. Why are we done there? Because there's no like terms. None of them are the same power, so none of them can combine further. So notice we can only add and subtract letters that have the same power, like terms, but you can multiply anything. Remember that? Some of that coming back? Questions on that one? All right, number 4. Foiling. Remember that? When you have two parentheses that are multiplying? So basically it's double distribution. In other words, the way it works is the first 2x will go to both of the other two. And then when he's done, the positive 9 will go to both of the other two. It's like they take turns, first to both, second to both. It's also called FOIL. It's the same thing, basically. So first to both, second to both. So now let me do it over here on the side. Oops. What is 2x times 2x? What is the rule for multiplying letter kind of things? Let me write it. You multiply the numbers in the front and you add the powers. So 2x times 2x, what are the powers? Invisible 1s. So you multiply the numbers in the front, 2 times 2 is 4, and you add the powers. It'll be 4x squared. Remember that? Multiply the numbers in the front, add the powers. So 2x times 2x is 4x squared. That's just the first of the 4 steps. And then the 2x also goes to the minus 9 at the back. That's minus 18x. He's done now. He's had his distribution. He visited the other two. It's like visiting your neighbors. They're taking turns. So the 2x went to both, and he's done. And now the positive 9 is going to go to both. So the positive 9 times 2x. What's that going to be? They're multiplying, right? So plus 18x, right? Positive 9 times 2x. And then positive 9, it's going to the back, times negative 9, minus 81. And these ones in the middle are going to cancel, aren't they? So notice how we do the multiplying phase first. We multiply out the parentheses. The parentheses drop, don't they? Once we do the multiplying, the parentheses drop off. And then we're in adding subtracting mode. And in adding subtracting mode, you're combining like terms, things with the same powers. These guys cancel. So what's our final answer? It's just 4x squared minus 81. Is that good? Questions on that one? Let's try number 5. On number 5, we have a 2 on the parentheses. What do we do with a 2 on a parenthesis like that? Yeah, it means there's 2 of them, huh? Yeah, 2 on anything means 2 of those, doesn't it? So that really means we have x plus 7 and another x plus 7, both in parentheses. And then we just FOIL it out again, which means first to both, second to both. Just like we did last time. Can you do that? Remember, those x's have invisible 1 powers, don't they? All right, let's try it. So that x is going to go to both. So x squared plus 7x. And then he's done. Is that good so far? I just took that first x and he multiplied both of the other 2. And remember, when you multiply letters, out front numbers multiplied, powers add, right? So the invisible 1 powers added. x1 made x2, x squared. And then x times 7, 7x. Now it's the 7's turn. He's going to go to both. Plus 7x plus 49. Now the multiplying's over. The parentheses are gone. So now we switch gears and we go into adding subtracting mode. And in adding subtracting, you're only going to add and subtract like terms, things that match. So which ones match?
7x.
Yeah, these two. So it's going to be x squared. These two. Now, is it 14x squared plus 49? No. It's just x, huh? Because we're adding right now. We're not multiplying. You only add powers when you multiply, huh? I'm adding 7x and 7x, so you just add the 7s. You don't mess with the x's. When do you mess with powers? When you're multiplying. But that was the first step. That's over. There's no more parentheses. There we are. We're done. X squared plus 14x plus 49. Want to try number 6? So we got a 2 on the parenthesis there, right? Right, 2 of them. Okay, I'm going to jump in and do it. So it's going to be 7x minus 4, 7x minus 4. So the 7x goes to both. Remember the rule, out front numbers multiply, powers add, right? 7 times 7 is 49x squared, because the invisible 1 powers on the x's add up. And then 7x times negative 4. Remember, that negative belongs to the 4, right? It's not really between the 7x and the 4. It's owned by the 4. It's his baby. Any sign in front of a number or letter, that's their baby. So 7x times negative 4 is negative 28x, isn't it? 7 times negative 4. 7x is done. So first to both, he's done. That 7x went to both. Now the negative 4 is going to go to both. Negative 28x plus 16, right? Because negative 4 times negative 4, 2 negatives multiply to be positive. Good so far? Multiplying is over. Parentheses are gone. Now we switch into adding, subtracting mode, which means like terms, huh? Which ones are like terms? Yeah, the ones in the middle again, huh? So we just bring that down. 49x squared. Combine them. 56x, 28 and 28, plus 16. Right, if you lose $28, it lose $28, negative 28, negative 28, you lost 56. You can just add them on your calculator if you need to. Is that good? Number 7, look at that. What's different about number 7? Third power. 3 of them. That's painful. So this is going to be, oops, writing it wrong. 3x minus 2, 3x minus 2, 3x minus 2. This is going to be a long one. So how do you do it? Well, first off, you should you just pick two of them. Like I'll just start with the back two. It doesn't matter, front two, back two, whatever. Just grab two of them, do the whole problem with two of them. When you're done, then grab the other one and let him take his turn. So I'll just do the back two first off. You know how this works. They FOIL. So I'm going to bring down the 3x minus 2 that's in the front, and then the back ones. 3x times 3x, 9x squared. 3x times minus 2, minus 6x. And then boom and a boom, minus 6x plus 4. We're partway there. See what I did? So I multiplied the back two. And then these two in the middle here, they're going to combine to make minus 12x. Let me write that down a little better. Good so far? So I just multiplied the back two like we've done a few times. And now the front one's going to have his turn. He's going to multiply all three in the other parenthesis, the answer we got from the other two, which is 3 items now, 3 terms. Am I losing you? This making sense? So this 3x now is going to go boom, 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 and hit all 3 of those. And then when he's done, the negative 2 is going to go boom, boom, boom. 6 multiplications altogether. And then we got to gather all those like terms. So if I'm going too fast, this will be on YouTube later. You can slow it down and watch it again. But I better keep moving so I can get through problems for y'all. So bring it up here. So as you multiply that, you're going to get 27x cubed minus 36x squared. Getting a little scribbly here. I'm trying to squish things in. Plus 12x. He's done. That's the 3x going to all 3. His turn's over. And now I'm going to let the minus 2. That's a minus 2. That negative belongs to him. It's his baby. He's going to take it with him wherever he goes. That minus 2 is going to go boom, boom, boom to all 3. So what are you going to get? Now I'm going to line up terms. It's helpful. Minus 18x squared. I'm going to line it up under the other x squared term because they're going to combine, aren't they? You don't have to do this, but it'll probably be easier for you. Next, minus 2 times minus 12. That minus belongs to that 12. That's his baby. Minus times minus plus 2 times 12. 24x. And then finally, the minus 2 goes to the plus 4. Minus 8. And now add them up. All the multiplying's over now. All the parentheses are gone. Now we add up the like terms, which I lined them up so the like terms would be more easily seen. You can do that on these messier ones. So bring them down. What is it? 27x cubed. Here we have minus 36 and minus 18. I don't know. What's minus 54? Thank you. 54x squared. And a choose calculator. Plus 12 and 24 is 36x minus 8. There we go. That was a lot of work. Good there? Questions on that one? All right. Number 8. Okay. So now, in one fell swoop, that was really a whole section in intermediate algebra we just did, and 7 quick reminder problems. And now, starting at number 8, we're going to factor. What in the world is factoring? Factoring is doing what we just did backwards. Factoring is the reverse of multiplying. In other words, they're giving us x squared minus 25, and they're saying, hey, what was that? Like it was 2 things, and they were multiplied, and it became x squared minus 25. What was it? That's what they're asking us. That's what factoring is. It's to find out, it's to multiply backwards, find out what it was before it was multiplied. just the reverse of what we just did. So how do you do that? Do you just have to kind of know it? Yeah, you got to spend enough time to where you can kind of see them. So what do you think that was? Probably some of you know already, huh? What was it that was multiplied there to become x squared minus 25? So let me give you a hint. So you got to have something in the front, and something in the back, something in the front, and something in the back. So the front times the front has to make x squared. What times what makes x squared? X and x. So they've got to have x's in the front, right? That's how we're getting that x squared. Good so far? Now, how are they going to get a minus 25 in the back? Well, there's got to be 5s in the back, huh? Because 5 times 5 will make 25. But how do you get negative 25? What kind of signs do you have to make the 5s multiply and come out negative 25? Can you have both negative? No, because 2 negatives would make positive. What do you got to have? One positive, one negative, and that's correct. It doesn't matter what order. You can put the negative first and the positive, whatever. It doesn't matter. But you have to have one of each to get negative 25, don't you? You could check it. You could FOIL like we just did, and it would become x squared minus 25. Okay, so that's one kind of factoring. That has a name. It's called difference of squares. I'm not going to quiz you on the names, but it might help you to keep things categorized. Because why? Because this was a square. This was x times x, and this was 5 times 5. We call those squares, meaning this was x squared, and this was 5 squared, wasn't it? That was a difference, a subtraction. Difference is subtraction. A difference of 2 squares. X, 5, 5. Whenever you see that, it factors like that. X is in the front, 5's in the back, 1 plus, 1 minus.
Is there a sum of squares?
That's a good question. Sum of squares actually doesn't work. Yeah. Why don't I leave it for now? It's a complex, it's a good question. We'll address it again later. Yeah, it's got to have a minus in the middle actually to work. Yeah, we better move on. So let's try number 9. So now number 9 is number 9 a difference of squares? No. 8's not a square, right? 8's not a number like 25. Like what times what is 8? Well, 2 times 4. It's not the same thing twice. Like 25 is 2 5s, same number twice. That's what we call a square. Something that comes from the same number twice, like 25 or 9, 3 times 3, or 4, 2 times 2. But 8's not a square. 8's just like 2 times 4. It's not the same number twice. Right. So it's not a square. Can't do it that way. Well, then how do we do it? Well, you look at these guys, and you actually first, anybody know, you ask what the GCF is. What do they have in common? Yeah, what goes into 8 and 2? 2. So you do that first. There's going to be more steps to this. But your first step is just to take out the 2. And then how do you know what's left inside? Whatever works. In other words, 2 times what will go back to become 8? 4, huh? And 2 times what will go back to become minus 2x squared? Negative x squared, huh? Everybody see that?
Could you factor out the negative 2 first?
Yeah, we will. Yeah, good observation, exactly. So far, so good? Now we have a problem. We have a problem. And yeah, it's exactly what's being said up here. That is, you've got to, we don't like the x's in the back when we're factoring. So when we're factoring, we like it like this, how the x squared was in the front. So do you know what will cause the order of subtraction to switch? That's what we want. We want to make that x squared go to the front and the 4 go to the back. What makes the order of subtraction switch? Have you ever spent time late at night and thought about what makes the order of subtraction switch? Probably. That's what weird math teachers do, huh? But that's my job. I have. Yeah.
Negative.
Negative in the front. Exactly. Let me show you. I don't want to just give you a rule, but let me show you it's true. What if you take like, I don't know, pick anything you want. 8 minus 2. What's the answer? 6. What if we switch it? What's 2 take away 8? Yeah, same answer, just negative, huh? So when you swap the order of subtraction, it's not like a totally different answer. It's the same number, it just switches the sign. So do you see, switching the order of subtraction, this wouldn't be the truth for adding, would it? That'd be a different story. But switching the order of subtraction just changes the sign. We use that a lot. We'll use that a lot this semester. So I'm going to say, oh, and I want this to switch. So what am I going to do? I'm going to make that a -2 in the front. And then it'll switch the order. Do you see that? Let me hold on for a minute and show you. We're still not done. We still have another problem because now we have a difference of squares. And we're going to break it down too. But before we go further, let me show you that it is true. If I was to multiply this out, I'm not really going to. But if I was to do it, what would I get? I would get -2x squared, right? -2 times x squared. And -2 times -4. What is negative times negative? +8. See how it's the same as the original? Now hold on. You might look at that and go, that doesn't look the same as the original to me, Mr. Heron. It's all, the order's all wrong. Right. Let me address that. It's a good comment or question. Order doesn't matter, actually. Signs in front are all that matter. You can swap around algebra terms all day long. It doesn't matter, doesn't change anything, as long as you take their babies with them. The sign in front of them has to travel with them wherever they may go. As long as they have the same signs in front, it's the same thing. The order doesn't matter. Signs in front matter. So what's the sign in front of that 8? Well, there's nothing in front of that 8. Right, so what does that mean? Positive. And what's the sign on the 8 over here? Positive. See how it's the same? What's the sign in the front of that -2x squared? Well, minus. What's the sign there? See, that's why I'm saying, what's my point in that? I'm saying this factoring, this trick we just did, where we said make the 2 in front negative and swap the order on the subtraction. See how it's really the same thing? I call that plastic surgery, just to help people remember. Try to use a weird word that'll stick in your mind, right? What is plastic surgery? You remove the wrinkles, they look different, same person when they're done. That's a lot of what we do in math. We just make this thing look different, but it's the same as it was. We just multiplied it out and saw that. See what we're saying? Now, why? Why are we making it look different? Well, because that's how it'll be easier for us to factor. Because now that we have the x in the front, things are a lot easier. Now that the x is in the front, we can finish up. How do can we finish it just like we did the last one? That x, the -2 just stays there. But we finish up the x squared -4 part. Because it's a difference of squares, isn't it? Right? So let me get rid of this. This was just to prove it was still the same. This is xx 2. Difference of squares. It's a subtraction of something twice. I call it a double-double. I like In-N-Out Burger. It's like a double-double there. xx 2. So you want to see that. It'll come up all the time. xx 2. It's a double-double. That's not the official name. It's a difference of squares. So when you see that, you go, oh, I know how to do that. X's go in the front. 2's go in the back, right? Because x times x in the front is x squared. 2 times 2 in the back is the 4. Just like we did up here with x squared -25. X is in the front, 5's in the back. And what do you do for the signs to make -4? What signs do those two? I haven't given those 2's their signs yet.
Positive and negative.
Well, one positive, one negative. Either order doesn't matter. We are done. There is the factorization of that one. So what did we do? Let's recap. We did it in 2 steps. 3 steps, really, huh? First, we took out what was in common. 2. They both had 2 in common. And then we realized, oh, if we made it a -2, that would switch the order. And that's easier. We like the x's in the front. It's just easier for us. Just for us. You don't really have to do that. It just makes life easier. And then we said, oh, that's a double-double. X 2. So x is in the front, 2's in the back, 1 plus 1 minus. Done. Questions I can answer on that one? All right. Like I said, this will be on YouTube. If that was too quick, you can see it again later. Number 10, we're rapidly changing. These would be whole, like those 2 we just did. Actually, each of those would be a whole lecture day, basically. And I just went bang, bang. In intermediate algebra, that's a whole day on taking out the common. There's a whole nother day on the negative and the swapping around. Because it's not simple. So that's why I said it's thick material. We're moving fast. So x squared -5 is this a totally different kind of factoring now. That's not a double-double. that's going to be 2 parentheses that somehow make x squared minus 5x plus 8. Do you remember how that kind of thing works? So we're looking for 4 numbers. Front, back, front, back. First off, they've got to make x squared. So what am I going to put in the front of each parenthesis? What times what makes x squared? Yeah, just plain x, Okay, that's good and all. Well, how do you know what's going to... Let's go to the back. Let's go back to the 8. We'll worry about the minus 5x in a minute. But we just did the fronts. Let's go to the backs. So what is going to multiply? What times what is 8? 4 times 2. 8 and 1. Are any of those going to work? Because they have to do what in the middle? They have to add or subtract, same thing, adding a negative is subtraction, to make the middle. And they don't work. 1 times 8 or 2 times 4, neither one is going to be able to make the middle term of minus 5x. What does that mean? The polynomial is prime, which means prime means cannot be factored. That's what a prime is, right? A number you can't break down. Well, this is a polynomial you can't break down. It's a prime polynomial. It cannot be factored. You can't break it down. The numbers just don't work. Now, if they had done it differently, if they had made that, like minus 9x in the middle, then I would have just said, or let's do 6. If they'd made minus 6x in the middle, then I would have said, oh yeah, make it minus 2 and minus 4. Right? Because those would multiply to be the plus 8, and they would add, minus 2 minus 4 would add to be the minus 6x, and that would have been my answer. It would have been great. Or if they gave me minus 9x in the middle, I would have done the 8 and the 1. Minus 8 minus 1. Because 2 negatives would multiply to be positive 8, and they would add to be negative 9x in the middle. But they didn't. They gave me crazy negative 5x. That doesn't work. That's a prime polynomial. All right, want to try number 11? Let me give you this tip now. The first step in factoring, let me write it. The first step in factoring, whenever you factor, the first step is to always try to take out a GCF. Do you know what GCF is? Greatest common factor, something in common with one big parenthesis. So in other words, the first thing you should always try on every problem that says the word factor, which is multiply backwards, is you should look at these 3 and you should say, is there some number that goes into all of them? Or letter? What goes into 6, 6, and 48? 6 does, right? And then what do you do with that? You put the 6 in the front and you do the one big parenthesis. And you put in, you just imagine that it's going to multiply to the 3 things on the inside, and you just figure out whatever works. That's the first step. And then after that, you try to do these other fancy things we've been looking at, like double-double or 2 parentheses with the numbers that add and multiply. But the first step is to take out what's in common. So x squared, x, and 8. Right? We good there so far? See how that's right? 6 times x squared will be 6x squared. 6 times x is 6x, and 6 times 8 is 48. Now, can we do more? We can try, but it won't work. The 6 stays in the front. Once that 6, he's going to be part of the final answer. We don't do anything else with him, but he will be there in the end. Now, you can try to do the 2 parenthesis thing again with the x's in the front like we tried up here. But it's going to be just like the last one. It's not going to actually work. Why not? Because the numbers at the back have to multiply to be the 8. What numbers multiply to be 8? 1 and 8 or 2 and 4. What number's in the middle here? There's an invisible 1 in the front. There's a 1 power as well. right? That's 1x. So 1 and 8, 2 and 4, they don't add to be 1, right? You multiply to be the number in the back. You add to be the number in the middle. Do you remember that? When you do the 3 terms, break it into the 2 parentheses. You're looking for 2 numbers that multiply to be the number in the back, like 2 times 4 is 8, and add to be the number in the middle. Well, they don't work, do they? So forget this. So what does that mean now? Do we say prime like the last one? No. Prime means you didn't even take 1 step. We took a step. We just couldn't take the second step. So our answer is this. That's our answer. It's not prime. So prime cannot be factored even 1 step. That's what prime means. If you couldn't even do 1 step, then the thing is prime. But we did 1 step. We took out the 6. We just couldn't do the next step. So, right? It's not prime. It is broken down to 2 things multiplied. Are we doing some of this coming back? Like a joyful memory from the past? No? Maybe. Questions I can answer on that one? All right, let's keep going.
Sorry, mister.
Question? Yeah, let me help with that one. Yeah, all these are a whole day of lesson in intermediate algebra. This one's problem, he's got another issue. So there's something new on every problem here. This one has got the minus on the x squared at the back. So basically, you want to read. See how they're out of order? See how they're not. Normally, you want highest power to lowest. You don't have to, but it makes it way easier. Just for our convenience, factoring is way easier to go highest power to lowest. So step 1, reorder. X squared, regular x, no x. You want it, that's no x there. You want it in order from highest power to lowest. So let's reorder it. Now, remember what I said a couple minutes ago. Order doesn't matter, but what does matter? You can move things around anytime you want, but when you move them around, take their babies with them. Take that minus sign with them. Right? I'll give you one quick story to stick in your mind. I said I had 5 kids, which is sort of crazy. When we got to I've enjoyed it, but it's a little crazy. When we got to our 5th one, I thought I had this figured out. Picked up my wife from the hospital. I mean, I was there with her, and then, went home. And so it's time to come home, and we always had to plan. We'd always go to, this is years and years ago. My youngest is 13 now. But we're coming home with little Abigail and from the hospital, and we always would just stop and have lunch, my wife and I, before we came home to a wild house of 5 children. So that was our tradition, bringing a new baby home. So we're on the way home. We stop for lunch with Abigail in the back. We stop. We jump out of the car, out of the little minivan, start heading into the restaurant. My wife looks at me and goes, "So do you think we should take Abby?" Or I'm like, "Oh yeah, we got a baby in the back. What am I doing?" So you should always take your baby with you, right? So those little minus signs, they're like that. That minus sign or plus sign, they go with it. So this little sign right there, and that little sign, and what's in front of the 63? Nothing, which means plus, huh? So when you move them around, take your baby take it with you wherever you go, right? That sign has to go. So that's going to become minus x squared plus 2x plus 63. That's the same thing. The order doesn't matter. Signs in front matter. So you do that first off. Now, here's our next issue. When there's a negative in front, we don't like negatives in front. It just makes things hard. Factor out -1, one big parenthesis, all signs change. Factor out -1. So when you have a negative, so first step is to reorder. Take the signs with them. Step 2, if the front term has a negative, are you tracking with me? The reason I'm having an issue here is because this front term has a negative on it. We don't like that. That just makes things messy. We want to do something about that. And so what we do is we factor out a -1, and it changes all the signs. right? We talked about that already, right? That changes signs when you take out a negative. So you put a negative 1 in the front, and then every one of these signs is going to change. X squared plus 2x becomes minus 2x, plus 63 becomes minus 63. By the way, do you see that this is still the same as the very first step? It's just plastic surgery. Just remove the wrinkles. It's the same person, right? If I was to multiply these out, it's the same as this still. You can see, right? Minus times x squared, minus x squared. Minus times minus 2x, plus 2x. Minus times minus 63, plus 63. Yeah, it's still the same on that. Yeah?
How did you get that negative 1 again?
I just put it there, brand spanking new.
Okay.
Yeah, so let me show it to you this way. Well, the reason is because of this minus right here in the front. I don't like minuses in the front. It just makes things messy and hard. So see how there's no longer a minus right on the x squared? That's what I'm happy about. That's what's going to make the rest of the problem easier. So that's the reason I'm doing it. Let me show you that it's true. But first off, do you understand my motivation? Why am I even doing this weird minus 1 thing? Because we have a minus on the x squared, the front term. You don't want minuses on the front term. It messes everything up sign-wise. This makes it really hard. So instead, the way to deal with that is you put a minus 1 in the front of the whole parenthesis, and that'll switch all the signs. Do you see? It's just like taking 7 minus 9 saying, oh, I'm just going to put a minus 1 in the front, and that switches the sign. Well, I could just change the signs as it stands. Makes it minus 7 plus 9. See how that's the same thing? That's all I'm doing. So, all right, now, okay, great, so what? Well, step 3, now finish the 3 terms, these 3 terms, with multiply in the back, add in the middle. Finish the 3 terms, 2 parentheses. So I'm going to say, okay, now the minus 1, he's still there. But now the 3 terms are going to break into 2 parentheses. Minus 1's still there. Remember, we put x's in the front. And we say, what multiplies to be minus 63 and adds to be minus 2? Remember how you handle 3 terms? So what times what's 63? 7 and 9. Use your calculator if you're rusty on some of these times tables. You use your calculator on everything, tests and homework and everything. And now, what signs do I need to have them make negative 2 in the middle?
Positive 7 and then minus 9.
Yeah. The sign in the middle goes on the bigger. It's the phrase I always use when I've taught intermediate algebra over the years. Sign in the middle goes on the bigger. So what sign is in the middle here? That's the middle term, right? There's 3 terms. He's the one in the middle. What sign does he have? Minus. The sign in the middle goes on the big. What do you mean bigger? Who's bigger? 7 or 9? Who's bigger? 9's bigger. Sign in the middle, the minus, goes on the bigger, on the 9. Right? Because the bigger one's going to dominate and make the result in the middle. So the minus 9 and the plus 7. 7 minus 9, that's negative 2. And so there is our final answer. You could swap the plus 7. The order doesn't matter. But you got to have all those parts there.